Okay, so this is our review, and this is the molecular shapes review. Okay, so here we go, molecular shapes. So we're trying to predict what shape molecules will turn into. And we're really going to focus on ones that have carbon, oxygen, and nitrogen in them. And we use what's called the valence shell electron pair repulsion theory, or VSEPR. And the way to kind of easily remember VSEPR is that lone pairs of electrons take up more space than bonded pairs. This is like your siblings, right? Ever feel like your siblings take up more space than you do? That's how I kind of feel about it. But it kind of makes sense because paired electrons are shared between multiple atoms. So they have more to interact with, whereas lone pairs are only bound to one atom. So they kind of take up more space. Okay, so we're going to do this activity with toothpicks and marshmallows. But if you don't have toothpicks or marshmallows, just draw these, okay? Now, so you've built the following molecular shapes, and I'm assuming that you can build them. And so I've drawn all the shapes for all of the molecules that they've listed. And so what we're trying to do is to assign each of these molecules a molecular shape. And so for this, you need to know your best friend. Your best friend has this little table here, and I'm going to show you real quick. Here, you have this table right here, molecular shapes. And so I'm going to switch back because I have it copied and pasted in on mine. So you can use this table to find the shape of any molecule. All you have to know are the definitions for each of the columns. So the first column says electron groups. So how many electron groups are around the central atom? Well, what's an electron group? An electron group could be a single pair of valence electrons, so that's 2 dots. It could be a single bond, that's 1 line. Could be a double bond, that's 2 lines. Or it could be a triple bond, that's 3 lines. Each of these individual things is one electron group. So the maximum number of electron groups that can fit around any atom without being an exception to the octet rule is 4. And that's what we're going to work with. We're not going to work with any exceptions. Then you have to know the outer atoms. So let's pick one to start with. Let's start with CO2. Let's start with CO2. So how many electron groups are around the central atom? Here's my central atom. What do we have that's from this list around the central atom? Well, this is a double bond and this is a double bond. So I have 2 electron groups. Now, I look at the outer atoms. Here's an outer atom and here's an outer atom. So I have 2 outer atoms and I have 0 lone pairs around the central atom. So all of these things are talking about what's around the central atom. So therefore, this shape must be linear and has a bond angle. This bond angle is 180 degrees. Okay. Let's do the next one. H2CCH2. So if we pick any of the, let me pick a different color. We pick any of the carbons, doesn't matter. Each one, they look exactly the same, so it doesn't matter. So let's pick this one. I'm going to look for electron groups. 1, 2, 3 electron groups. And then I'm going to look around that central carbon and I'm going to say, well, how many outer atoms does it have? It has 1, 2, 3 outer atoms that surround it and no lone pairs. Therefore, it is trigonal planar. Okay. CH4. If I look at my central atom right here, I've got 1, 2, 3, 4 electron groups. Of those 4 electron groups, let's see how many outer atoms I have. And I have 1, 2, 3, 4 outer atoms. And I have no lone pairs. Therefore, this one is tetrahedral. Then I have NH3. NH3, if we look at this one's a little bit different. I have 1, 2, 3, 4. I have 4 electron groups. So I'm still here. I have 4. But I only have 1, 2, 3 outer atoms, and I have 1 lone pair. So it must be pyramidal. Ooh. Pyramidal. So you see how that's working? All you have to do is be able to read this chart. Look at water. Water has, let's see, 1, 2, it's oxygen, the central atom. The oxygen has 1, 2, 3, 4 electron groups. That's right here, 4 electron groups. How many are outer atoms? Well, only 2 are outer atoms. 2 are these lone pairs. And so it is bent. And so when we talk about the VSEPR theory, that electrons are pushing down on, these lone pairs of electrons are pushing down on the bond angles. I want to show you a little something. I just have too much written on these pictures here. So I want to show you these 3, the last 3 that we did. Okay. So for CH4, we said CH4 was tetrahedral. So this bond angle from here to here, and here to here, here to here, and here to here, these are all 109 degrees. But if you look at NH3, what happens is that this electron cloud is really kind of big. This is the space where the electrons can go. And so it kind of pushes down on these. So now this bond angle is not quite 109 anymore. It's just a little bit less than 109. You don't have to remember the exact number, but just know that it's a little bit less than 109. Then if you look at water, water now has 2 lone pairs. So each of these has this really big sphere of space that it can take up, which pushes down on these bonds. So now my bond angle here from bond to bond is less than 109 degrees. So the bond angle gets smaller as we convert those electrons from being bonded pairs to being lone pairs. Okay, so now complete the following table. And we did this. We did these Lewis structures and we identified the molecular shape. So now we're just kind of doing it in reverse. And so what I'm going to do is I added another column to this, and I said, okay, electron groups around the central atom. So this is kind of what we did first. And we said, okay, there are 2 electron groups around my central atom. I have 0 lone pairs, and I have 2 outer atoms, and therefore I am linear. And so that works here, because if you say you had 2 electron groups, 2 outer atoms, 2 lone pairs, you're linear. So all you're doing here is filling back in what we did before by just circling things. So if you look at H2CCH2, you have 3 electron groups, right? You had 3 bonded outer atoms and no lone pairs. And you can pick either carbon, doesn't matter. You get the same result. Tetrahedral, you're going to get 4, but the same thing is true about trigonal pyramidal and about bent. They all have the same number of electron groups around the central atom, but what's different is how many of those are bonded atoms. If they're all bonded atoms, they're tetrahedral, D-R-A-L, tetrahedral. Anyway, it's spelled wrong. Then in trigonal pyramidal, you have 3, and in bent, you have 2. So in tetrahedral, you have no lone pairs, trigonal planar, trigonal pyramidal 1, and bent 2. So that's all you have to do is go in and fill those in. Okay, the next one we're going to do, I'm assuming that you know how to draw the structures. So I'm going to go in with the structures drawn and just kind of fill this table in. So if I look here at this carbon, it's got 4 different things around it. It's got 1, 2, 3, 4 electron groups. Of those 4 electron groups, let's see, of those 4 electron groups, 1, 2, 3, 4 outer atoms surround that central carbon and no lone pairs. So what kind of a molecule am I? So if I go down here and I say 4 electron groups, 4 outer atoms, 0, my shape is tetrahedral. Tetrahedral. Okay, do the next one. The next one, I have only, if I pick a carbon, I'm going to pick this carbon right here. I have 2 different electron groups around my central atom, and those 2 outer atoms and no lone pairs. So if I do that, I go 2 electron groups, 2 outer atoms, no lone pairs. I am linear. Okay. All right. Let's do our next one, CH2, CHCl. Okay, this one, pick any of either one, you're still gonna have the same shape. So you pick the first carbon. I have 1, 2, 3 areas of electron groups. Then I have 3 outer atoms, and you can kind of look and you're like, there's no lone pairs. So I have, oops, don't erase. I have 1, 2, 3 outer atoms. Oh, and I didn't write that. I have 3 electron groups, I have 3 outer atoms, and I have no lone pairs. So 3 outer atoms, no lone pairs. I am trigonal planar. Trigonal planar. Okay. NH4, ooh, and that's a plus. It looks like some of my stuff got erased. Oh. NH4 plus, it's carrying a positive charge, so you have to make sure to include that in your drawing. So this one has, let's count them, 1, 2, 3, 4 areas of electron groups, and then I have 1, 2, 3, 4 outer groups, and I have no lone pairs. So this is tetrahedral, just like the one up above. Okay, the last one. Pick any carbon. Oops. Pick any carbon. I'm going to pick this first carbon, and I'm going to say I have 1, 2, 3, 4 groups around it. I have 1, 2, 3, 4 outer atoms, and I have no lone pairs, so that makes me tetrahedral. Okay, so just get in the practice of the habit of doing it. So based on our tables, does the number of atoms attached to a central carbon affect its shape? Yes, it does, right? So list the shapes that carbon atom can adopt and the number of atoms attached to the carbon in each. We're going to use our little chart to answer that, but I want to come back to this question first. So yes, we know that the number of atoms attached to the central carbon affect its shape. So really it's about, is it a bonded pair of electrons or is it a lone pair of electrons? So the number of electron groups, right, matters. That's one thing. And the second thing is, are the electron groups bonded or lone pairs? That's the 2 things that we have to look at. And so if you look at carbon, what can carbon do? Well, carbon, it has 4 valence electrons, so it wants to make 4. So if it has 4 areas, it could be all 4 areas have atoms and no lone pairs, so then it could be tetrahedral, right? If carbon, on the other hand, makes, let's say, a double bond, right? So now we have 3 areas of 3 electron groups. That's how you call it, electron groups. So then I'm going to say I have 3 electron groups. And in this case, I'm going to have 3 outer atoms and no lone pairs, and I'll be trigonal planar. Then I could have carbon double bonded to something on either side, or I could have carbon in a triple bond and a single there. So either way, I have 2 electron groups. I'll have 2 outer atoms, no lone pairs, and therefore be linear. So these are the different things that carbon can do, right? All right, now oxygen, on the other hand, is a little different, right? So we have to look at some molecules that have oxygen, some molecules that have nitrogen, because we can't just focus on carbon. So here's an example of a compound with nitrogen and oxygen. We want to predict the shape around the nitrogen and the oxygen atoms in the molecule. So let's start with nitrogen. Nitrogen, how many electron groups do I have? Well, 1, 2, 3, and don't forget 4 is our lone pair. Okay, so if I have 4, let's do a different color. Let's do nitrogen and pink. I have 4, and then of those 4, I have 1 lone pair, and I have 3 outer atoms, so I am pyramidal. Right? Okay, so that's a bond angle of a little less than 109. Now my oxygen, on the other hand, my oxygen, I have 1, 2, 3, 4 groups. So 4 again. 4 is very popular. But in this case, I only have 1, 2 outer atoms, and I have 2 lone pairs. So therefore, this oxygen is bent, and it's less than 109 degrees. Okay, not too bad. So what would we expect our bond angle about the nitrogen or the oxygen to be smaller? Well, the bond angle between the oxygen is smaller because we have more valence electrons that push on those bond angles. So even though we drew this linearly, really this oxygen has a hydrogen here, and then its nitrogen comes off, and then you can draw the rest of the molecule. But really this bond angle got squished because of these valence electrons that are taking up so much space. Okay, vinyl acetate. This is one that is carbon-based, but it also has some oxygens in here. So let's kind of see if we can identify the shape of the different atoms in this Lewis structure. So my carbon number 1, I've just numbered them 1 through 4, just to make it a little bit clearer which carbon we're talking about. So if I go to carbon 1, and I go, okay, I have 1, 2, 3, 4. I have 4 electron groups. I have 1, 2, 3, 4 atoms. So 4 electron groups, 4 atoms, no lone pairs. This is tetrahedral. Okay, so then I'm going to go to carbon number 2. Here's carbon number 2. I'm going to go, let's see if I can erase. Okay, so I go to carbon number 2. Here's carbon number 2. Wow. Okay, carbon number 2. And I'm going to say I have 1, 2, 3 areas of electron groups. Then I'm going to look at my atoms, and I have 1, 2, 3 atoms and no lone pairs. So 3 and 3 makes trigonal planar. Okay, now let's erase that one. And we're going to go to carbon 3. Yeah, let's see, green. Here's carbon 3, highlighter. Carbon 3, and I have 1, 2, 3 areas of electron density. It is terribly hard to see. I have 3 areas of electron density, and I have 1, 2, 3 atoms that surround that carbon. So 3 and 3 makes it trigonal planar. Okay, last one, carbon 4. So I'm going to look, and I have 1, 2, again, 3 electron groups. And then I want to know how many atoms. I have 1, 2, 3 atoms surrounding. So that makes it, again, trigonal planar. Okay, so not too bad.